The Sun, our very own star. A churning, fiery giant that holds our solar system in its gravitational embrace. It is a force of unimaginable power, capable of both breathtaking beauty and terrifying destruction. And right now, it's undergoing a dramatic transformation. The Sun's magnetic field has flipped. We have entered solar maximum. This is not a time for alarm but for awe, for understanding. The Sun, like any dynamic force of nature, operates in cycles, and we are now witnessing the peak of one of its most powerful cycles, the solar cycle. Every 11 years the Sun's magnetic field weakens, reverses, and strengthens again. This process is marked by an increase in solar activity, culminating in what we call solar maximum. This is not just some distant cosmic phenomenon. Solar maximum has a direct impact on our planet. It can trigger stunning auroras, disrupt our technology, and even pose a threat to our power grids and satellites. But it also reminds us of our place in the cosmos, of the raw power of the universe we inhabit. Buckle up, as we take you on a journey to understand the mysteries of the Sun's magnetic field flip, and the thrilling ride that is solar maximum. Deep within the Sun's fiery heart lies a secret, a churning dynamo that drives its magnetic field. This dynamo, a product of the Sun's rotation and the movement of charged particles within its plasma, is responsible for the Sun's 11-year cycle and the dramatic magnetic flip we are witnessing. Imagine a giant magnetic field line stretching from one pole of the Sun to the other. As the Sun rotates, these field lines become distorted like rubber bands twisted beyond their limit. Eventually they snap and reconnect, reversing the Sun's magnetic poles. North becomes south and south becomes north. But this is no simple flip of a switch. It is a gradual process, a slow buildup of magnetic energy that culminates in a dramatic reversal. And we are currently riding the crest of this wave, witnessing the Sun's magnetic field in its most volatile state. This current cycle, Solar Cycle 25, began in December 2019 and is already proving to be more active than predicted. Scientists are observing an increasing number of sunspots, those dark, cooler regions on the Sun's surface that are associated with intense magnetic activity. And with more sunspots come more solar flares and coronal mass ejections, the Sun's way of releasing its pent-up energy. The Sun is a celestial artist, and solar maximum is its grand performance. During this period of heightened activity, the Sun's surface erupts with breathtaking displays of energy, each more awe-inspiring than the last. Sunspots, those dark blemishes on the Sun's surface, become more numerous and pronounced. These are not mere cosmetic imperfections, they are windows into the Sun's turbulent magnetic field. Imagine colossal loops of plasma, guided by invisible magnetic forces, rising from the Sun's surface. These are solar prominences, graceful arcs of fiery gas that can stretch for hundreds of thousands of kilometers into space. And then there are the solar flares, sudden, intense bursts of energy that release radiation across the electromagnetic spectrum. These dazzling explosions occur when magnetic energy stored in the Sun's atmosphere is suddenly released, unleashing a torrent of radiation that travels at the speed of light. But perhaps the most awe-inspiring phenomenon of solar maximum is the coronal mass ejection, or CME. Imagine billions of tons of plasma, a superheated cloud of charged particles, being blasted into space at millions of kilometers per hour. These CMEs are the Sun's most powerful eruptions, and when directed towards Earth, they can have significant impacts on our planet. While the Sun's dance of energy may seem like a distant spectacle, its effects can be felt right here on Earth. When CMEs collide with our planet's magnetic field, they trigger a cascade of events we call geomagnetic storms. These storms can disrupt our technology, cripple our power grids, and even pose a threat to astronauts in space. Imagine the sky ablaze with vibrant colors, shimmering curtains of green, red, and purple dancing across the night. These are auroras, the most beautiful side effect of geomagnetic storms. Caused by charged particles from the Sun interacting with Earth's atmosphere, auroras are a reminder of the interconnectedness of our solar system. But the beauty of auroras belies the potential danger of geomagnetic storms. In our increasingly technology-dependent world, even minor storms can have significant consequences. Imagine satellites malfunctioning, GPS signals going haywire, and radio communications being disrupted. These are just some of the potential impacts of geomagnetic storms. And as we become more reliant on space-based technologies, the stakes only get higher. Section 5. When the sun strikes back, historical solar fury. Throughout history, the sun has reminded us of its raw power, unleashing solar storms that have left their mark on our planet and our civilization. In 1859, the Carrington event, the largest solar storm ever recorded, plunged parts of the world into chaos. Telegraph systems went haywire, with some operators reporting electric shocks and fires. The northern lights, usually confined to high latitudes, were seen as far south as the Caribbean. It was a stark reminder of the sun's power and the vulnerability of our technology, but the Carrington event was not an isolated incident. In 1921, a powerful solar storm known as the New York Railroad Superstorm caused widespread communication outages and even sparked fires in railroad equipment. In 1989, a geomagnetic storm caused a major power outage in Quebec, Canada, leaving millions without electricity for hours. And in 2022, a solar storm knocked out a fleet of newly launched Starlink satellites, highlighting the increasing threat posed by space weather to our space-based infrastructure. These historical events serve as stark reminders of the potential consequences of solar storms and the importance of understanding and preparing for these celestial events. Section 6. The Carrington Event, A Telegraph's Tale. The year was 1859. The telegraph was a marvel of its time, enabling near-instant communication. Little did they know, the sun was about to test this technology. On September 1st, Richard Carrington witnessed an extraordinary event. A blinding flash erupted from the sunspots. He had witnessed the most powerful solar flare ever recorded. Earth was bombarded by charged particles. Telegraph systems went haywire. Sparks flew, setting offices ablaze. Operators received shocks, and systems operated autonomously. The northern lights were seen as far south as Cuba. The world was in awe, unaware of the sun's havoc. The Carrington event reminds us of the sun's power and our technology's vulnerability. Section 7. Predicting the sun's fury, the science of space weather. Just as we monitor earthly weather to anticipate storms and hurricanes, scientists are constantly watching the sun, striving to predict space weather and the potential impacts of solar storms. This field of study, known as space weather forecasting, is crucial for protecting our technology, astronauts, and power grids from the sun's fury. Using a fleet of ground-based observatories and space-based telescopes, scientists track sunspots, solar flares, and CMEs, analyzing their trajectory and potential impact on Earth. These observations are fed into sophisticated computer models that simulate space weather, providing forecasts and warnings of impending geomagnetic storms. Just like weather forecasting on Earth, space weather prediction is not an exact science. The sun is a complex and dynamic object, and its eruptions can be unpredictable. However, with each passing solar cycle, our understanding of the sun's behavior improves, and our ability to forecast space weather becomes more accurate. The goal is to provide enough warning time to take mitigative actions, such as putting satellites into safe mode, protecting power grids from voltage fluctuations, and ensuring the safety of astronauts in space. Section 8. Bracing for the solar storm, preparedness and mitigation. As we enter solar maximum and the potential for solar storms increases, it's more important than ever to be prepared. Governments, space agencies, and power grid operators are taking steps to mitigate the risks posed by space weather, hardening infrastructure, developing early warning systems, and creating contingency plans. One crucial aspect of preparedness is raising public awareness about space weather and its potential impacts. By understanding the risks, we can take steps to protect ourselves and our technology. This includes having a plan for communication outages, securing backup power sources, and staying informed about space weather forecasts. Just as we have learned to live with hurricanes and earthquakes, we must learn to live with the sun's occasional outbursts. By understanding space weather and taking appropriate precautions, we can minimize the disruptions caused by solar storms and continue to enjoy the benefits of our technological society. Remember, knowledge is power, especially when it comes to the sun. Section 9. The Sun's Dance, a never-ending cycle. The sun's magnetic field flip and the arrival of solar maximum are not isolated events. They are part of a never-ending cycle, a celestial dance that has been going on for billions of years. As our nearest star, the sun's influence on Earth is undeniable. It provides the light and warmth that sustain life, but it also has the power to disrupt our technology and remind us of our place in the cosmos. As we continue to explore space and rely more heavily on technology, understanding and adapting to space weather will become increasingly crucial. The sun's dance may be eternal, but so is our quest for knowledge and our ability to adapt. By embracing the challenges and opportunities presented by solar maximum, we can continue to push the boundaries of human exploration and understanding.